Hello and welcome to one-on-one tutorials. Please visit our website at www.oneontutorials.hostgi.com. Okay, now let us continue where we have left in the last tutorial. We have been discussing about potential difference. Okay, now definition wise, a potential difference is the amount of work done in moving a unit charge from one point to another in an electric circuit. Okay, so that is the definition. So potential difference is nothing but work, the amount of work done in moving unit of electric charge, because when you move an electric charge, you are moving against an electric field, because the same charge will always repel, so you have to do some work, and that is the potential difference. Now how to calculate? Okay, so let us derive a formula, because we will be also working on some numerical problems in this chapter. Okay, now as I mentioned, the potential difference is the amount of work done. Okay, so potential difference is equal to, potential difference is always for potential difference we always use the letter V, but like voltage. So the formula is V equal to that is potential difference equal to work done, that is in the numerator it is work done, divided by quantity of charge moved. See, as you see, the definition is, it says work done in moving a unit charge. So that because it is a unit charge, so we have to divide by the quantity of charge moved. That means we are getting the amount of work for 1 unit of charge. So just remember this formula, because when you will work on numerical problems, we will be using this formula very often. Now, what is the unit of work? Unit of work is joules. What is the unit of charge? It is coulomb. And unit of potential difference is volts. So we can say that we can write a simple formula as V equal to J upon C. That means 1 volt equal to 1 joule upon 1 coulomb. Okay, that means if I have to do 1 joule of work to move 1 coulomb of charge across 2 points in an electric circuit, we will say that the potential difference between these 2 points is 1 volt. Okay, we'll when we work out on problems, we will explain this multiple times. So let us remember this formula, V equal to J upon C. So potential difference between 2 points is said to be 1 volt. So this is interesting, is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of charge between from one point to another in an electric circuit. I hope this is not so difficult. Remember this formula, 1V equal to 1J by 1C. How do you measure potential difference? To measure potential difference, we use an instrument called voltmeter. It's simple. Volt is the unit for potential difference from voltage, and meter for measuring. I'll show you a diagram of a voltmeter. Yeah, see the upper one? This is a typical diagram of a laboratory voltmeter. Of course, nowadays a lot of handy voltmeters are also available, and they are called multimeters. That means in one instrument you can measure multiple things, voltage, ampere, lot of things you can measure, resistance. Okay, but that is the diagram of a laboratory voltmeter. Now if we have to measure the potential difference across 2 points, I am showing this zigzag by as a conductor. It can be anything, it can be an electric lamp, it can be an electric iron, it can be any electric equipment. If I want to measure the potential difference across 2 points, I have to connect this voltmeter parallel to this conductor. Why parallel? First of all, a voltmeter will have a very high resistance. Any voltmeter will have very high resistance. So if there is a resistance is very high, the electric current will not pass through it. So electric current will try to pass through the through that route where the resistance is very low. So electric current will not pass through the voltmeter. So we can get the exact potential difference across these 2 points, point A and point B. Okay, I have not mentioned A and B, just across the left and right point. So remember, a voltmeter, we can measure the potential difference by connecting parallel. And why parallel? A voltmeter will have a very high resistance and therefore current will not pass through the voltmeter. So we can measure the exact potential difference across these 2 points or between the left and right point of the conductor. Okay, so this is the formula: V equal to J upon C.